Hello guys, today we'll be solving O Level Physics 5054 October-November 2024 paper 2-2. Let's start. Okay guys, question number 1. A jet ski is a type of a boat that carries one or more people and travels at high speed on the water. Figure 1.1 shows the student riding on a jet ski. Alright, this high speed jet of water is forced backwards out of the back of the jet ski by a pump inside the jet ski. The pump increases the momentum of the water that is forced backwards out of the back of the jet ski. Complete the word equation to show the relationship between the resultant force on an object and the change in momentum of the object. Okay. As far as the word equation for resultant force is there, so resultant force is going to be equal to rate of change of momentum. Whenever they ask you what is resultant force, in general, it's always equal to the rate of change of momentum. But over here, there's a specific term that they added. They ask you to show the relationship between the resultant force on the object. So as far as the object is concerned, the momentum is increasing. So you can give your answer along these lines that it's going to be rate of increase in momentum. Increase in momentum. That's pretty much it. Moving on. In 2 seconds, the pump increases the backward speed of 180 kgs of water by 30 meters per second. Calculate the backward force. So according to my equation, force is going to be equal to rate of change of momentum. Since I need the force, the mass is 180. The final speed of the water was 30. Initially, the speed of the water was 0 and the time was 2 seconds. So I can get the force by just multiplying 180 by 30 over 2, because 180 times 0 would be 0. So if I use my equation over here, 180 times 30 divided by 2, I would get the force as 2700 newtons. So keep a calculator in your hand. It's going to be 2700 newtons. Okay, moving on to the next part. Okay, for this question, they're saying that using Newton's third law of motion, explain why there is a forward force on the jet ski. Why there's a forward force? So Newton's third law states that every action force has an equal and opposite reaction force. So if there's a force on an object A, it would and you hit an object, there would be equal and opposite force that would be exerted back on the object B. So if I want to answer this, I can say that this jet ski is going to exert a force on the water. So according to Newton's third law, this water will exert a backward and opposite force on the jet ski as well. So my answer is going to be along these lines. Jet ski is going to exert a force on water according to Newton's third law. What's going to happen? The water is going to exert an equal and opposite force on the jet ski. An equal and opposite force, on the jet ski. That's going to be pretty much it. Moving on to the next one. A student has a mass of 70 kilograms. So a student has a mass of 70 kgs and the jet ski has a mass of 280 kilograms. Use your answer from A2 to determine the acceleration of the student and the jet ski with no resultant force present. So from A2, I already have the force, that's 2700. If I need the acceleration, I can say since F equals ma and the force is 2700, over here, since the jet ski has human on it, so the mass is going to be the combined mass that is going to be accelerating. So mass is going to be 70 plus 280. So mass, we always going to be going with the total mass, because these both objects are basically one object in this case. Okay, and I need the acceleration. So 2700 is going to be divided by 70 plus 280, and I would get the acceleration as 7.71. I would just write it as 7.7 since I need all my answers in two significant figures. Moving on. The jet ski reaches the speed of 20 meters per second. Okay, so finally the jet ski reaches the speed of 20 meters per second, and I need to calculate the total kinetic energy of the student and the jet ski at the speed. Okay. As far as the kinetic energy is concerned, it's going to be half mv squared. So kinetic energy is going to be 1 over 2. Again, the masses are going to be combined since they are single body. So 70 plus 280, and the speed is 20, and I have to square that. So I'll just put everything in a calculator. So half times 70 plus 280, put it in a bracket and then times it by 20 and then square that. We would get the value of kinetic energy as 70,000. So that's very neat answer. So 70,000 joules is going to be my kinetic energy for this. That's question number 1.
Guys, question number 2. A glass beaker of mass m is at rest on a horizontal surface. The base of the beaker is a circle with radius r. The beaker exerts a pressure on the horizontal surface. Determine an expression for the pressure in terms of gravitational field strength, mass, and radius. Okay. So pressure is going to be equal to force over area. So pressure is equal to force over area. We have got the force. So basically the force is going to be the weight. And again, weight can be given as mass into gravity. Whereas since it's a beaker and it's written that the beaker is a circular base, so the area would be given as pi r squared. This is a very rare question. I haven't seen this come anytime before, but I have explained such a question in my lecture of pressure. The first or second case, second case of pressure, we have experienced this. So this can be asked, this in the case for the four-legged object. They can be asking that anytime in your examination. So make sure that you look at that as well. So weight is going to be mass into gravity, area is going to be pi r squared. So this is going to be the equation in terms of m, g, and r. Moving on. Figure 2.1 shows a beaker being filled. So beaker being filled from a liquid from container X. Initially the beaker is empty, so the beaker is empty initially, and at time t equals 0 the tap opens and the liquid from container X flows slowly into the beaker. Okay. At time t equals t the liquid stops flowing into the beaker. Okay, sketch on figure 2.2 to show how the pressure exerted on the horizontal surface varies between time 0 and time 2t. So there was an empty beaker. Definitely, if the beaker is empty, this beaker would be exerting some pressure to the ground. So the graph can't start from 0. It has to start somewhere above, like right above 0. Okay. Now, since the liquid is flowing at a constant rate, that means the mass would increase at a constant rate. We just discussed that pressure equals to mg over pi r squared, the formula that we derived above. So if I increase the mass, the pressure would increase at a constant rate. We know that the gravity and the radius and everything other than that is constant. So since the pressure would be exerted, like increasing at a constant rate, the graph would be a constant gradient line. At time t, there's no more liquid that's flowing. So at time t, the liquid stops flowing. So since the liquid stops flowing, that means at this point there would be maximum pressure. And after that, it's just going to be a straight horizontal line. The pressure would be constant after that. So the pressure would remain constant after that. So that's pretty much it for question number 2. Again, there's some pressure because of the mass of the beaker. The pressure increases as the water in the beaker increases. At time t, there's no more water that is going to be flowing in the beaker. So this is the maximum pressure point, and this would remain constant till a point somebody put out some water from the beaker or pour some more water in. So till then, the pressure is going to be the same. That's all for question number 2.
Okay, so question number 3. Question number 3, figure 3.1 shows a laboratory freezer. The door is closed and the freezer is switched on. So the quick liquid is pumped through the, a cold liquid is pumped through the copper pipes. These copper pipes are going to be having a very cold liquid. At the top of the freezer, the temperature of the air next to the copper pipe decreases quickly. Explain how the temperature of the rest of the air in the freezer decreases. Okay, let me just explain that. Let's say these copper wires, they're very cold. These copper wires are very cold. So the air molecules that are near these copper wires would definitely lose their heat on the copper wires. They would become more dense and go down. We have all discussed the concept of convection in all the questions previously, the convection was usually asked by heating the liquid or gas from the bottom. Over here, they are doing it the opposite way. They're cooling the liquid. So, air molecules that are near the copper pipe would lose their energy and become more dense and would sink down. So, air molecules, because they're being cold, they would sink down, resulting in the less dense and warmer molecules to come up and replacing them. So this is basically the process of convection that's happening. We discussed this in the chapter of transfer of thermal energy. You can look at that lecture over here as well. I would place the link in the description. So in that particular lecture, I explained how the process of convection actually happens in the freezers and the air conditioners. So you can look at that. Okay. So explain how the temperature of the rest of the air in the freezer decreases. I would answer along these lines that air near the copper pipes. So air near the copper pipes loses their energy, their energy cools down, becomes more dense, and sink at the bottom. At the bottom. This would result in a convection current. This would result in formation of a convection current, and hot air, warmer air, I can say. So hot is not the correct word, I guess. They won't detect the marks, but I think warm air would is the correct word. So warm air would move up, would replace them and move up. Therefore, temperature decreases by convection. So by convection, the process of temperature would decrease, and these are all the key points. So convection, make sure that you write the process of convection down, convection currents, anything. So that's all the convection setup. So that's going to be pretty much it. Okay, for question part B, the thick insulation shown in figure 3.1 is made from plastic material. Okay, so plastic is a bad conductor. There's an insulation that is made from plastic material. All right. They're saying that the plastic material is an insulator, poor thermal conductor as an insulator. Describe how the thermal energy is transferred to the plastic material. So we have discussed in our lecture as well. Again, this is very common question, that how heat is transferred through plastics. So plastic, since it's not a metal, it transfers energy by colliding with by a collision between the neighboring molecules. So again, particles of plastic would vibrate, transferring energy to the neighboring molecules by collision or you can say by the process of conduction. So they're just going to be conducting heat, moving fast and then vibrating and transferring energy to the neighboring molecules, and throughout the heat would be transferred. Okay, the plastic materials also contains a large number of small air bubbles. Okay, so the plastic insulators basically contains a large number of air bubbles. Explain how the air bubbles reduces the transfer of thermal energy through the insulation. So air bubbles transferring the thermal energy through the insulation. So I would answer along these lines that since air is trapped in the middle, it would reduce process of conduction and conduction as well as convection by great extent, since it's a very bad conductor of heat. Since it's a very poor conductor of heat, Always remember, air is the worst conductor of heat. Worst conductor. It's a very poor conductor of heat. So the answer is going to be along these lines. That's pretty much it for question number 3. Moving on to question number 4.
All right, let's move on to question number 4. So question number 4 states that figure 4.1 shows a large syringe that is sealed at the nozzle by the wax. There's a piston inside the syringe and the pressure of the air inside the syringe is equal to the atmospheric pressure. Okay, so the pressure inside the syringe is equal to the atmospheric pressure. The value is given. The volume of the air inside the syringe is also 1.2 times 10 to the power of negative 4. So the volume of water, that is volume of air that is inside the syringe, has this value volume. The area of the end of the piston is 3.5 times 10 to the power of negative 3. So this area is 3.5 times 10 to the power of negative 3. The friction between the piston and the syringe is negligible. So the friction is negligible. Calculate the force on the piston due to the pressure of air inside the syringe. Okay, so you're required to calculate the force that is exerted on this part, the face of the piston. Again, you're just going to be using pressure is equal to force over area, and since you have the pressure that is 1 times 10 to the power of 5, you're required to calculate the force. You have the area as well, that's 3.5 times 10 to the power of negative 3. This is just going to be multiplying these two values. So what 1 times 10 to the power of 5 multiplied by 3.5 times 10 to the power of negative 3. When you multiply them, you would get the value as 350 newtons. So 350 newtons would be the value for the force. Moving on. The force on the piston in A1 acts at the right. Explain why the piston does not move to the right. Okay, so he's saying that this force acts on the right and the piston is not moving. So what is the reason for that? The reason is already in the question. So they're saying that the pressure of the air inside the syringe is equal to the atmospheric pressure. So always remember that the pressure exerted by the atmosphere is equal to the inside of the pressure. So there's no extra pressure and the pressure are balanced. So you'll start your answer along this line that pressure inside the cylinder is syringe, sorry, the pressure inside the syringe is equal to the atmospheric pressure outside. That's one. So pressure inside the syringe is equal to the atmospheric pressure that's outside. So that's one. Second, if anything is to be moved, Newton's first law states that if an object is at rest, it will remain at rest, and if an object is moving, it will keep on moving until and unless there's a resultant force on it. So there's no resultant force. There is no resultant force. So to move, you need a resultant force. There's no resultant force, and all forces are balanced. So that's why it is not moving. So if something's at rest and they're asking why is it at rest, very common answer is it does not have a resultant force. So in order to move something, you always require a resultant force. You always require some extra force in order to move this object. That's pretty much it. So the answer is going to be along those lines. Part B. The piston is now pulled to the right by an additional force. The temperature of the air in the syringe does not change. So the temperature of the air inside the syringe is not changing. Explain in terms of the particles why the pressure of the air in the syringe decreases. So explain in terms of particles why the pressure of the air in the syringe decreases. So again, that's a very common question. Saying that the piston is moved to the right. So piston is moved to the right, and the piston is moving to the right, and the temperature is not changing, but the pressure is changing. So very basic answer for this. First of all, when the piston will move to the right, so there's going to be Boyle's law. So I'll answer according to Boyle's law. We all know that pressure is inversely proportional to volume. So pressure is inversely related to volume. If pressure increases, the volume decreases. So, and if the volume increases, the pressure decreases. As volume increases, particles would have particles will move separate. So particles are going to be separating, and that's the first line. So particles are going to be separating, and what would happen is they would be further apart. So particles are going to be separating, they're going to be further apart, which would cause less collision, which would cause less frequent collision between them and between the walls. Hence, pressure would decrease. Okay, moving on. Calculate the pressure of the air inside the syringe when the volume of the air is 1.5 times 10 to the power of negative 4. Okay, so that's a very good question. So P1 V1 equals P2 V2. I'm going to be using the Boyle's law formula. They want us to find the pressure at this particular volume. We have a known pressure and a known volume as well. So we have a known pressure. That was basically the atmospheric pressure where the volume was this. So I can call this P1 and I can call this V1. So 1 times 10 to the power of 5 multiplied by 1.2 times 10 to the power of negative 4 equal to P2 is going to be unknown. We don't know the P2 and we know the V2. That's 1.5 times 10 to the power of negative 4. So any known pressure and volume would give the same value as another known pressure and volume. That's the Boyle's law. It states that pressure and volume are inversely related, keeping other physical conditions temperature constant. So always remember that it's only applicable when the temperature is kept constant. 1.5 times 10 to the power of negative 4. So the value that I'm getting is 80,000. So you can write the pressure as 80,000 pascals, or you can write it as 8 times 10 to the power of 4. Whatever suits you. Both are totally all right. Thank you. All right, guys, question number 5. So some glass lenses are converging lenses and the others are diverging lenses. Draw a cross section of a diverging lens. So for a diverging lens, it's drawn somewhere like this. So there are like these curves that are going inwards. The very bad at drawing, but yet again, okay. So this is going to be a cross section for a diverging lens. Moving on. In figure 5.1 shows a cross section of a converging lens. The principal axis and the two principal focuses f1 and f2 on a full scale grid. All right. Use the student places the object of height 2.1 centimeters at a distance of 3 centimeters from the center of the lens. Using figure 5.1, determine the focal length of the lens. So each box is of 1 centimeter. So the focal length is 1.2, 4, 6, and 8. So 1.8 centimeter is the focal length that I'm getting. Use figure 5.1, draw the vertical arrow of height 2.1 centimeters and 3 centimeters from the center of the lens and label the arrow O. The arrow is the object. Okay, label the arrow O. Just for my understanding, I'm going to be making a 2F as well. So 2F is going to be 3.6 centimeters. 2F is twice the focal. So just for the understanding purposes, I'm going to make a 2F. Then I'm going to place an object that is going to be 2.1 centimeter heighted at 3 centimeters. So 3 centimeters and 2.1. So the object is going to be over here, exactly over here. I'm going to make an arrow to it, and then they're asking draw two rays from the tip of the object to make the image. So let's make the image as well. So let's take two rays, one straight horizontal ray, and a second ray would pass from the optical center undeviated. Okay, ray that's gone straight to the principal axis would converge and pass from the focal. That's always the case, and then this is going to be the image. So image is going to be over here somewhere, so it's going to be 3.1. The image is going to be 3.1 centimeters. So the image is going to be 3.1 centimeters. Use the image marked on figure 5.1, determine the linear magnification. So linear magnification is the height of image over height of object. Height of image I'm getting as 3.1. Height of object already given in the question is 2.1. So 3.1 divided by 2.1, I would get the linear magnification as 1.47. Let's call it 1.5. So the linear magnification that I'm getting over here is 1.5. So that's the linear magnification. Explain whether the image of the object is real or virtual. So for my case scenario, for any case scenario like this, the image is going to be real. It's a real image because light rays are actually meeting. Real image as light rays are meeting, or you can say converging at a point. So if light rays meet or converge at a point, then the image is always a real image. That's it for question number 5. So moving on to question number 6. Alright guys, question number 6. Figure 6.1 shows a circuit symbol for a relay and two labeled terminals. By referring to figure 6.1, explain the effect of the current passing from A to B. Okay, by referring to figure 6.1, explain the effect of the current passing from A to B. Whenever there's a relay switch and the current is passing from the magnetizing coil, this is the case that the current magnetizes the magnetizing coil, which creates a magnetic field around the magnetizing coil, and this magnetic field attracts the relay switch, and that's the case. So the answer is going to be along these lines, that current in AB would magnetize the magnetizing coil, and there will be a magnetic field around it. There will be a magnetic field around it, which would attract the relay switch. So which is going to attract the relay switch. So that's it. All right, part B. Figure 6.2 shows two circuits linked by a relay. The heater transfers energy at a rate of 40 watts when it is connected to a 12 volt supply. Okay, switch S is closed, the variable resistor is adjusted so that the resistance R increases from 0. All right. Figure 6.3 shows how the power transferred in the 40 watt heater varies as R increases from 0. The graph shows a sharp decrease when the resistance R reaches RH. Okay. Explain the shape of the graph in figure 6.3. Very good question. If you look at the graph, as the resistance is increasing, the power is not changing. At resistance RH, the power reaches 0. So the power is of the heater and the resistance is of the variable resistor. So let's say the switch S is closed. So switch S is closed and there's a current. So there's a current, and initially the current is large enough to actually allow the magnetizing coil to attract the relay switch and hold the relay switch in the position. When I'm increasing the resistance of the variable resistor, the power supply is still of 12 volts. The power over here is also constant. So as I'm increasing the resistance of the variable resistor, what is happening is that the current in the circuit will start to reduce. At resistance RH, the current would reduce to a point that this relay would no longer be able to pull the switch towards it and hold it in position, and therefore there would be no current in the secondary circuit, and eventually the heater would have the power that is equal to sorry, the power that is equal to 0. So that's what happening over here in this particular question. So if I'm going to be answering it along these lines, listen to me very carefully. It's a very good question. Initially, the current is large enough. So initially the current is large enough. So initially the current is large enough to actually pull the relay switch in. So actually attract the relay switch and allow the heater to run. As resistance increases, so as resistance would increase, the current in magnetizing coil would decrease. At resistance equals RH, the current would be insufficient. Current in magnetizing coil is going to be insufficient to pull the relay. So current is going to be so much insufficient that it won't be able to pull the relay, and yet again the power in the heater would be 0. Since power equals VI, and if the current is 0, therefore the power would also be 0. Okay. The 40-watt heater connected to a 12-volt supply is connected. Calculate the energy transferred in the heater in 2 minutes. So energy equals power into time. So energy you're required to calculate, the power is 40 and the time is 2 minutes and then 60 seconds. So 40 multiplied by 2 multiplied by 60, you would get the answer as 4800 joules. Last but not the least, the resistance of the heater. So resistance is the ratio of voltage to current. Over here we are not given the current, so we have the power, so we can use power equals VI to calculate the current first. So 40 is going to be the power, voltage is 12. I can get the current, 40 divided by 12, the current value is 3.33. Then I can use this value to get the resistance. So 12 divided by 3.333. So 12 divided by the value is going to be 3.6. So the resistance is going to be 3.6. That's it for question number 6.
Alright guys, so question number 7. So the frequency of an alternating current main electric supply is 50 Hz. So the frequency of electricity main supply is 50 Hz. The maximum voltage of the supply is 300 watts. Using the axis on figure 7.1, sketch the graph of show how the voltage of the power supply varies at, okay, so frequency is given. Since frequency is equals to 1 over time period, I can calculate the time period and I would get it as 1 over frequency, that's 1 over 50 is equals to time period, which would be 0.02 seconds. That means in 0.02 seconds, one complete wave would be formed, and the wave would have a voltage of 300 volts as the maximum voltage because it's an alternating current. So if I need to complete my wave at 0.02, there's going to be a maximum, there's going to be a minimum, and that's going to be it. So half wave would be formed in 0.01 and the complete wave would be formed in 0.02. The waves are going to be continuing, so it's an alternating current. This is going to be pretty much it. So yeah, I think it's going to be 2.5 waves form, and that's 3 mark. You draw it a little neatly. I'm very bad at it. So again, moving on. So figure 7.2 shows the main power supply connected to the primary coil of the heat of the transformer. The primary coil consists of 750 turns. Right. So the core of the transformer is made from iron. Explain why iron is a suitable material for the core of the transformer. Okay. So iron basically is a temporary magnet material. So iron is basically a soft magnetic material. It's a soft or a temporary magnetic material. So that is why it is used. So soft or temporary magnetic material, whatever suits you. is going to be the answer for this. Explain why there's a voltage across the secondary coil. So again, it's just going to be how the working of the transformer works. So the alternating current in the primary coil induces an alternating magnetic field in the soft iron core. Always remember, since there's an alternating current in the primary coil, this induces an alternating magnetic field in the soft iron core. So this alternating magnetic field interacts with the secondary coil, and that causes the rate of change of magnetic flux. Hence, EMF is induced in the secondary coil. So explain why there's a voltage in the secondary coil. This question has been asked a lot of times. There's the same answer for that. Let's rewrite this down again. So alternating current in the primary coil, induces an alternating magnetic field in the soft iron core, which interacts with the secondary coil and causes a rate of change of magnetic flux. Hence, EMF is induced in the secondary coil. Hence, EMF, or in this case voltage, whatever suits you, is induced in the secondary coil. So this is very important. This question comes a lot of times. It's very common. So these are the same lines that are asked over and over again. How the transformer works, how the secondary coil has its own voltage. So this is the perfect 3 lines that you can write for 3 marks. Okay, there are 60 turns in the secondary coil. So there are 60 turns in the secondary coil. Again, since they're asking about the turns, they're going to be NP over NS. Number of turns in primary over number of turns in secondary is equals to voltage in primary over voltage in secondary. So number of turns in primary you are required to calculate, I guess. Calculate the maximum value of voltage across the secondary coil. Okay, now this would be given. Okay, so number of turns in the primary coil are given. That's a 750, and number of turns in secondary coil are 60. Voltage in primary would be given. So the frequency in alternating current, the maximum voltage of supply is 300. So the voltage is given in the first part. So voltage over here is 300. So again, you're going to be using 300 as a voltage. So 300 is the voltage in primary, and voltage in secondary is unknown. So 60 would be multiplied by 300 and then divided by 750. The value of voltage in secondary would be 24 volts. That's going to be it for question number 7. Let's move on to question number 8. Alright guys, question number 8 is basically for radioactivity and nuclear physics. Describe the composition of alpha particles. Pretty simple. So alpha particles would have 2 protons and 2 neutrons. No electrons, but 2 protons and 2 neutrons would be there. Okay, state the name of the particle that is identical to the composition of alpha particle. So the alpha particle is identical to helium nuclei. You can remember that beta particle is equal to the electron. So alpha particle is equal to the helium nuclei. Okay, the alpha particle decays or decay at thorium-233 produces an isotope of radium. Okay, alpha decay of thorium produces an isotope of radium. The number of neutrons in the neutral atom of the isotope of radium. Okay, very good question. So thorium is 230 and 90. It decays an alpha particle and it becomes radium. So alpha is 42. Definitely, to balance the equation out, radium would have a mass of 226 and it would have a proton number of 88. Since they're asking number of neutrons in the radium atom, so radium atom neutrons would be 226 minus 88, which would be equal to 138. So that's the answer. Okay, that's a logical question. I don't know why they have given just 1 mark for it. I think it should have been of 2 marks. Moving on. The number of electrons in the neutral atom of isotope of radium. Again, neutral atom always have equal number of electrons and protons. Since radium has 88 protons, it would have 88 electrons as well. The half-life of thorium is 75,000 years. The radioactive sample contains this many amount of thorium atoms. Determine the time for the number of thorium atoms to decrease to this particular value. Okay. So that's pretty good. 7.2 times 10 to the power of 16 would decrease to half of its value. So 7.2 times 10 to the power of 16, when it would be half, it would be 3.6 times 10 to the power of 16. Again, it would be half to become 1.8 times 10 to the power of 16. Again, it would be half to become 9 into 10 raised to the power 15. So there would be how many half-lives? There's going to be 1, 2, and 3 half-lives to start from here and reach till here. So since there are going to be 3 half-lives, so since the time of one half-life is 75,000 years, if you multiply it by 3, you would get the total time it would require to reach that particular value, which is going to be around 2.25 times 10 to the power of 5 years. So 2.25 times 10 to the power of 5 years would be the correct value for this half-life. Moving on. When it decays, thorium-230 also emits gamma radiations. Figure 8.1 shows a narrow beam of gamma radiations passing into an electric field. Okay. On the figure, sketch the path of gamma radiations in the electric field. So gamma radiations are neutral radiations. They have no effect of magnetic field, nor they have effect of any electric field. So gamma radiations are going to be moving undeviated without any change in direction. So the path of electric field replaced by the magnetic field, and sketch the path of gamma radiations. Again, they're still going to be going straight. They're not going to be deviated anywhere because they are gamma radiations. Gamma radiations have no effect on the neither from the magnetic field nor from the electric field. So both are going to be straight lines, horizontal lines, not moving anywhere. That's pretty much it for question number 8.
All right, let's move on to question number 9. So question number 9 is the last question for this paper, and again, the question is very good. So the Earth has a radius of 6.4 times 10 to the power of 6 meters and rotate on its axis once every 24 hours. Figure 9.1 shows that the Earth rotates from an object on the surface of the Earth moves in circular path around the axis of rotation. Very good. Calculate the speed of the object at the equator as it moves in a circular path around the axis of rotation. So if an object is over here and it's moving in a circular path, that would mean that the total distance that it will be covering would be 2 pi r. Since it's a circular path, the distance that is going to be covering is going to be equal to the circumference. So the speed is going to be equal to 2 pi r over t. So 2 pi, the radius of the Earth, is given as 6.4 times 10 to the power of 6. 6.4 times 10 to the power of 6, and the time is going to be 24 hours, in which that's going to be 60 minutes and 60 seconds. Since your speed is to be calculated in meter per second, I'm going to go with this. So 2 pi times 6.4 times 10 to the power of 6, and then also divided by 24 times 60 times 60. The value is going to be 465. So 465.4, and your examiner usually give your answers in two significant figures. So 470 meters per second is going to be your value for this. Okay, moving on. So the next part is that explain why the speed around the axis of rotation of an object of the Earth decreases as the distance of the object from the equator increases. They're saying that this circular speed decreases as I go up. So if I'm over here, my speed is less. Down there, the speed is less, and the speed is maximum at the equator. This is a really unique concept, never been asked before, but let's understand this. If something is over here, that means the circumference that it's going to be covering is going to be much less compared to that when it's on the equator. So the circle, if you look at a circle, and if you move a circle, the point over here has to cover a bigger distance compared to the one that's near the poles. So the answer should be along these lines, that as we move away from the equator, the circumference reduces. Hence, less distances to be covered with in the same time. So speed decreases. And that's pretty much it. Moving on to the B part. The Earth moves around the Sun because a force acts on the Earth. State what provides this force. All right. So to keep any object in a circular motion, you need a centripetal force. In this case, the centripetal force will be the gravitational force. So gravitational force from the Sun actually acts on the Earth to allow it orbit. Again, so moving on, the orbit of the Earth around the Sun is ellipse. Okay, to describe what happens to the magnitude of the force that acts on the Earth as it moves in an elliptical orbit. That's very good question. So, if you look at an elliptical orbit, let's say this is the Sun, and let's say the circle that I drew is basically the orbit of the Earth. So Earth is moving like this. Just for understanding, it's not that elliptical, but okay. So as the Earth seems to be moving towards the Sun, this gravitational force, that force starts to increase. And when the Earth is moving away from the Sun, like if the Earth is moving away from the Sun, it seems the Earth is moving away from the Sun in an elliptical orbit. This gravitational force seems to be decreasing. So when, in easy words, the gravity is maximum when the Earth is towards the Sun, and the gravity is minimum when the Earth is away from the Sun. So the answer is going to be along these lines, that these forces, this force of gravity changes, the force of gravity varies. So it always does that. So in the force of gravity is always going to be varying, and when Earth is moving towards the Sun, it increases, and it decreases when the Earth is moving away from the Sun. So your answer is going to be along these lines. Last but not the least, explain why the Earth travels the slowest when it is furthest distance from the Sun. We have always discussed the concept of a comet. If you remember the fact that when the Earth is towards the Sun, the kinetic energy is maximum and the gravitational potential energy is minimum. When the Earth is moved away from the Sun, the furthest distance from the Sun, the kinetic energy is minimum and the gravitational potential energy is maximum. So always remember, whenever the question like this comes up, you always have to remember, explain why the Earth travels the slowest when it's at the furthest distance. So at the furthest distance, kinetic energy is minimum and gravitational potential energy is maximum. That's going to be the first statement. So the kinetic energy is going to be the minimum and the gravitational potential energy is the maximum. So Earth is moving at the least speed. So Earth is moving with least speed when it's away. So yeah, that's pretty much it for this whole exam paper. I hope you benefited from that. Do subscribe, comment, and follow the channel. Take care, guys.